All right, we're going to get into 4.3 today. We're still going to be talking about logarithms, but we're going to spend a little bit more time with some of these properties. We talked about some of the properties that deal with logarithms as far as um, being able to recognize if they have like the same base and the same number that follows the base, and being able to like simplify an expression like that. So we're going to continue to kind of talk about those things, but we're going to add some new properties in today that will also maybe come into play when you're trying to solve for a logarithm expression. We're going to talk about some rules that are called like the product rule, quotient rule, and power rules, and how you would use those to either expand or condense logarithmic expressions. And then we'll also talk about the change of base property. All right, so we're going to start by going over how we would expand logarithms. And you can kind of see that they have the three rules that I kind of mentioned listed out here. We've got our product rule, our quotient rule, and our power rule. What the product rule says is that if you have a logarithm and they have like the same base, so the same like little subscript number next to that log, and you have two quantities on the inside, so it could be like a number and a letter, it could be an expression, and something else like that they're putting inside of a set of parentheses or like some type of grouping brackets, you can actually split those terms apart and make them each individual logarithms. You can do the same thing with division, but division would just mean instead of separating it apart and adding a plus sign in between the two quantities, you would change it to a minus sign. And then the power rule says that you can kind of rewrite something within that logarithm form. You can kind of move some of those numbers around, which we did a little bit of in the last section. We were talking about some of those properties with logarithms. We were like maybe moving numbers to become exponents or changing the way that the original problem looked in order for us to simplify it. So we're still going to see a little bit of that happening when we talk about our power rule. So for an example of the product rule here, if I had something that started out that looks like this, log base 5, and then in the parentheses they wrote 25 times 7. Because it's multiplication, that's what product means. That's a key word for multiplication. This means that I should be able to separate these two pieces out and put a plus sign in between them. So it should be log base 5 of the 25, and then log base 5 of the 7, and notice how they just put a plus sign. Whoops, let me get a different color there. They put a plus sign there in the middle, okay? Something else that they might do then is if you start to rewrite things, the reason why we do that is because sometimes it makes it easier then for us to solve things and like be able to actually simplify the expressions. So what they did next here is they rewrote this as log base 5 still, but they took that 25 and they made it become 5 squared. The reason why they're doing that is because it's going to start to look like that property that we talked about from the last section, where now that these two numbers match, the 5 here and the 5 here, that this whole piece crosses off, and then this 2, that was the exponent, that comes out. And you remember maybe seeing that in the last section. We talked about looking for those kind of things because it helps us simplify our expressions. Okay, so that 2 comes out. We can't do the same thing with the log base 5, 7, because you can't rewrite that 7 as something raised to a power. You have to just leave it as is. Okay, so what would you guys write for this next one here if you were going to try to separate it out? What would it say? Good. Yep, you would start by just putting a plus sign, but you're separating it so it says log base 3, 5, and then plus log base 3, 4, and you got that plus sign in the middle. Very good. Now in this one, you really can't do any rewriting like we saw in the example because the bases are 3s, and there's no way to take a 5 or a 4 and rewrite that as 3 raised to some power in order to maybe get things to cancel off. So I think at this point, this is about as simplified as it's going to get, and you're just going to leave it here. Okay, but that's what the product rule looks like. You take things that have a multiplication sign in between them, you separate them apart by putting a plus sign in them. Now, underneath this, we have the quotient rule, which honestly is very, very similar to the product rule. It's just instead of multiplication, you're going to see division. Okay, so you're going to have a division problem, and when we rewrite this one as separating it out, instead of doing plus sign, we're going to do subtraction. Okay, so product means addition, like when you're separating them out. Division means subtraction. Okay, but the same rules apply here. So if I look at this next one, and they did just change it to an ln, that's your natural log. Okay, that's we're going to handle it the same way as we would a regular logarithm though. The ln is going to get paired up with the e to the 5th power, because that's what was on top of my fraction here. And then that 11 is going to become its own, but we're going to put a minus sign here. So it's going to say ln 11. Okay, if you think back to the last section though, what happens here when it says lne? Yeah, it just crosses itself off basically, okay? So this is gone. The 5 is going to come down as just a 5, and then you still have minus ln and then 11. And if you want, you could put 11 maybe in parentheses. If you feel like your 11s, your 1s, and your l's for log start to look too similar, you could always put symbols around that if you needed some separation so that it doesn't look like you're just writing ln, ll. Okay, I know sometimes those can look a lot alike. All right, why don't you guys go ahead and write down what you think the next one would look like. All right, tell me what you guys put down. Very good. Log 7x minus log 713. Again, there's really no rewriting we can do with that. We can't make the x or the 13 become 7 but raised to a power. So we're stuck with just kind of leaving it there. All right, any questions on the product rule or the quotient rule? Okay, so we've got one more to talk about, and this is the power rule. So on the top of the next page, the power rule is basically when you start to have something that already has a power and it's raised to another power. So you might see like multiple exponents happening here. Or if the number that follows the logarithm has an exponent, sometimes we may not want to work with the exponent because it makes the numbers really, really big or maybe really hard to work with because it just gets to be a little bit unmanageable. So instead of having to deal with it the way it is, we can actually move the exponent elsewhere in the problem to maybe make the number that follows the logarithm easier to deal with. Here's what I mean. On that first example, see how it says log 6 and then 3 to the 9th power. 3 to the 9th power would be a really big number, okay? Because you're taking 3 times itself 9 times. I mean, 3 to the 3rd power is already 27. So like it starts to get really big really fast. So it may not be in my best interest to work with 3 to the 9th power because that's going to be a really large number. I maybe don't want to deal with that. So what I can actually do is take this 9 and I can move it to the front. That's basically all I'm going to do here with my power rule is I'm going to move the exponent to a different spot in the problem to maybe make the rest of it a little bit easier. So I'm going to put the 9 in front, and I'm just going to write everything else the way it is. Log, base 6, and then the big 3. Now, if I was actually solving this, then maybe I would set it equal to x or whatever it is that I'm trying to solve for, and then maybe start to work with that a little bit, okay? But in this case, I can't really do anything with this, but it's just kind of demonstrating how this product would work, or this property would work, I mean. Okay, now this next one where it says ln and then the 3rd root of x here, remember when something is underneath a root like this is really saying it's ln, and then if you think about the x, it would be x to the 1/3 power. We might want to write it like that so we can actually see the exponent, because sometimes as a square root, they're a little bit disguised as far as like what the exponent looks like, okay? Now the exponent is that 1/3, so I'm going to take this piece only and I'm going to move it to the front. So this is now going to say 1/3 and then ln and then still just x. Okay, so on the last one here, what would you rewrite it as? Yeah, this 2 is the only thing that you're going to move. So that's just going to go in the front. So it's going to say 2 and then now log, and then we would still have x plus 4. Okay, So why don't you guys practice that here with these next three. Go ahead and rewrite those using the product or the power rule. All right, how would you rewrite the first one? Very good. What's the next one look like? Okay, so tell me where you got the number that you put in front of the log. Okay, so you are thinking of the square root is really like 5 to the 1/2 power. Very good. Okay, and then you took the 1/2 and you stuck it in the front. Good. That's perfect. Okay, how about the last one? What'd you guys do? Good, just move the 4. Great. There you go. All right. So that's one way that we can kind of use those rules. We can move things around. And like I said, the reason why we do that is because sometimes it helps us make something easier for us to solve, or we can start to see if I move this piece over here, I'm going to be able to kind of rewrite this, or I can get those bases to look the same. I can start crossing logs off and just deal with regular numbers. Okay. So in doing those three different properties that we just talked about, we can then expand log expressions or we can condense them. We're going to start with practicing with just expanding first. So expanding means that you're going to have like a single logarithm that's got a lot of information kind of all condensed down together. And then you should be able to take that logarithm and kind of break it apart or like stretch it out. So that's what I'm going to show you how to do first. So this first example here, I've got log base b, and then in the parentheses it says x to the 4th power, and then the cubed root of y. Okay, so what I'm going to do first is I'm going to try to apply either my product rule or my quotient rule. Since the quantity is on the inside of the parentheses there's no like fraction bar. That means like no division is happening. It looks like just multiplication is going on. I'm going to start with my product rule to separate these out and put a plus sign in between them. So I'm going to rewrite this as log base b of x to the 4th plus log base b of the cube root of y. Okay. Now remember that this quantity here is the same thing as y to the 1/3 power. So I'm just going to kind of rewrite that. Because I have exponents, I may want to move those exponents using the product rule, or I'm sorry, the power rule. I keep saying product, I mean to say power rule. Sorry about that. And I'm going to take these exponents, the 4 and the 1/3, and I'm going to move that up to the front of my logarithms. So I'm going to rewrite this first one now as 4 times log base b of x. And then for the second one, I'm going to put the 1/3 in the front and then do log base b of my y. Okay, so you can kind of see there, I use the product rule first in order to separate them out and put a plus sign in between. And then I used my power rule in order to move those exponents to the front of the problems. Again, maybe if I was actually trying to solve this, or if I had some actual numbers in here to work with, that might just make the process a little bit easier. Okay. Now right underneath this, we're going to do the same thing. But if you look at this next one here, see how there is like a fraction inside of the parentheses. Remember, fraction means division. So we're going to actually want to start out with our quotient rule. Okay, so I'm going to begin by separating these out. I'm going to write log base 5 of the square root of x. And since it's division, we're going to do minus instead of plus. And then it's going to be log base 5 of 25y to the third. Okay, now something else that I'm noticing over here is that after the log 5, I have a 25 and I have a y to the third. Those two quantities, the 25 and the y to the third, are actually being multiplied together. So if I wanted to separate this even more, if I wanted to expand it even one step further, I could, because those are being multiplied together, which means I should be able to use the product rule for that. So I'm going to leave the first one alone. The only thing I might do here is rewrite this so it says x to the 1/2, just because we saw up above on the other example with that radical that we wanted to move that. So I'm just going to rewrite it with that 1/2 as the exponent. Okay, and then we have minus. Now over here I'm going to write log base 5 of 25, and then plus log base 5 y to the third. Okay, so I just kind of separated those out just even a step more. And then I think there's maybe only one other thing we can do here, which is to work with those exponents. Now, not all of them have exponents. Well, actually, let me hold on a second there. I'm getting ahead of myself here. Okay, let's kind of backtrack for a second. I was talking about these exponents. Like, we know we can move these, right? Okay, so let's go ahead and do that. 1/2 log 5x. I'm going to skip over that middle term for a second, and then plus 3 log 5y. Okay, I hesitated on that just a second because I was looking at that middle term, and there's something that we can do with this. Does anybody see what I saw? So you have that base, that little subscript of 5, right? What can I do with this 25? 25 is the same thing as 5 squared, right? So I could say this is minus log 5, and then rewrite the 25 as 5 squared. And then what is something else that I could do here? Yeah, the log 5s, like these are gone, and this 2 is what's left over, right? So that 2 is just going to come out, and everything else about the problem is going to stay as is. And so this is your final answer here. Okay, so kind of involved. Like there was the quotient rule. We started out with that. We then followed up with the product rule. The product rule. Then we used the power rule a little bit, but then we also were able to rewrite that expression in the middle to simplify it even more, and we got rid of the logarithm altogether. So you can see how I'm using a lot of these properties all within the same problem, and you guys are going to be seeing that too. Like you're going to be using a lot of different properties all at the same time. Okay. So if you guys turn your page over, I want you guys to go ahead and try this problem on your own. See what you can do with that. Do as much as you can. Try to get rid of as much or simplify as much as you can there. Okay, someone tell me kind of what you did here. What was your first step? Okay, then what did you do? Okay, was there anything else that you could do here? Good. Everything else is the same? Yep, okay. And then what's the last thing that you noticed you could do? Yeah, there's a lot of twos there, right? So like all of that's gone, and what are you left with here? Just this two. And then everything else stays as is, right? There was nothing that we could really do with these other expressions. Good. Nicely done. All right, questions on expanding those out. Okay, so if we can expand logarithmic expressions, we can also condense them too. So we can kind of go the reverse. Like if I had something that was written out as like maybe even like this step is maybe what you're going to be more likely to see, is I can take that and I can actually squish it all together and make it one logarithm expression. And that's what we're going to do next. We're going to practice how do we go backwards, okay? We can still use the same rules. So they're showing you those properties that we talked about, product rule, quotient rule, power rule, kind of how to go in the reverse with them. So we're still doing that. And then down here, they're showing you an example. Okay, so I'm just going to kind of walk through what they did here. So we're starting out with, I'm going to just kind of do some highlighting. We're starting out here with it saying log 25 plus log 4. So those were two separated things. And the first thing that they did is because there's a plus sign here, plus sign means that there's going to be a multiplication sign in between them. So that's why they're changing it to just a regular log, and then in parentheses are writing 25 times 4. 25 times 4 is 100, so that's how they get to that next part here where it says log of 100, okay? Do you remember though, when you have a log and there's no number as the base, what number is technically sitting there? Yeah, there's technically a 10 down here, okay? And because the person knew that, they then took 100 and they rewrote it as something with a base of 10. So they rewrote this as log, I'm just gonna squeeze that little 10 in there again, log 10 and then 10 squared, because then the last thing they saw they could do is get rid of all of that and just write out the 2, and that's how they got their final answer of just 2. Okay, so they started out with the condensing using that product rule, and then they rewrote that 100 as something with a 10 to get it to cancel off a little bit even more and get rid of the log entirely. Okay, we won't always be able to do that. Like if you look at the next example here, this one starts out by saying log, and then it says 7x plus 6, and then it says minus log x after that. So on the top, log 7x plus 6, they're kind of putting that above the x here. They started out because they're seeing, okay, there's a minus sign here. Minus means that there would be division going on. Okay, now they didn't quite finish this one because on the top of this, if this is addition, what could I do with those two? I should be able to multiply them, right? So I'm going to take this a little step further here. And I would take 7 times 6, which would be 42, and then x all over x, like so. Now I would say, I don't know if you necessarily have to do that. Like if the quantity is 7x plus 6, I mean, you could, that would basically be me like distributing this log into both of them. So it would be say like log 7x and then plus log 6. I don't necessarily know if you have to do that. It might be helpful, and some people might even argue, well, can I get rid of these x's? You might be able to even do that. I think they're maybe leaving it back here just because they're thinking about if I had like an actual x. I'm trying to think. I'm starting to doubt myself here if I should have even gone that step. I might do some thinking on that problem, and I might even just do some looking up and see if that's something I could do. Maybe for right now, I'm just going to erase this and just kind of leave it here where we just condensed it with just using the quotient rule. Let me take a look at that, and I'll circle back to that maybe when you guys are working on your homework today, okay? Yeah, I'm wondering if because it was already a quantity that has the two terms separated. I don't know. I could see going either way. So let me dig into that one a little bit more, and then I'll provide some clarification. Okay. All right. Let's go on to the last one here. We're almost done here with our section, so let's just keep trucking along. So we've got two. Again, I'm going to highlight the original problem. We've got 2ln x plus a third ln times x plus 5. So we've got some numbers sitting in front of the natural logs. So those are going to be those exponents using your power rules. So they move the 2 up as an exponent, and they move the 1/3 up as an exponent as well. And then the plus sign in the middle here, right there, means that we should be able to condense this even more by multiplying those quantities together. So you can see they've got ln and then x squared times x plus 5 to the 1/3. And then the only other thing that they did is they rewrote this because it's 1/3. They rewrote it as a square root. Well, not a square root, but a cube root using the property that we know that those fractions, if you have a term raised to a fraction, that's talking about rooting something. So they were just kind of, again, doing a little extra rewriting. All right. I want you guys to go ahead and try these three on your own. Yeah, and maybe this one is going to be like that one that I'm questioning a little bit. So I would go ahead and just do that one how it looks up above in the example, okay? Okay, let's go ahead and go through these here. What'd you guys do on the first one? Okay, you multiplied them, and that's how you got the 12. Okay, perfect. Okay, how about the next one? Good, yeah, and let's just leave it there for right now. Okay, and how about the last one? Okay, good, yeah, because this would come up here, so that would say log x to the fourth. and then this 2 would come up here, and 5 squared is where you guys got the 25 from. Since there's a minus sign in the middle, that's why you guys were dividing. Good. Okay. All right. Last thing we need to talk about is a different property. We've not talked about this one yet. This is called change of base property. So this would be when you have like a single logarithm, and you have a base number, and then they have a number that follows it. What you can do is apply the base, and kind of like separate this almost into 2 separate logarithms, and then you just divide to solve it. You'll have to just use your log button on your calculator to do these. So A could be, or the base can be any number. If we're doing it on our calculator, that base is going to be 10, okay? But so you can see how they're going to rewrite it as log of the big number, m. That's going to go on the top, and then on the bottom is going to be log, and then whatever your number is for your base, that's going to follow it. So like down below, they're showing you here if we had log base 7 of 8, they would take the log 8 and put that on top, and they would take the log 7 and put that on the bottom, and the 7 does become like a big 7. And then you just use your calculator for this. So on your calculator, you're going to have to use your log button and do log 8 and then divide by log 7. You're going to get a decimal for this. The same thing can be applied when you do the natural log. So if you do the natural log of 8 over the natural log of 7, so this could be written like this, ln, and then there's maybe a 7 here and then an 8 there. The same thing would happen where you could split those apart. Either way, you're going to have to use your calculator to do that, because you're going to have to use the actual button to find the answer here. And when you guys do that, you should get the same answer both times. I got 1.07 when I did it, so you should be doing the same thing, or if you type it in, you should get the same answer as I did. Okay, so how would you guys split apart this one? What would it look like if you split it into the fraction? Yeah, log 9 over, good, log 2, big 2. And then you would just type that on your calculator. So go ahead and do that and tell me what you get. Yeah, go ahead and round it out to 2 decimal places like I did. .17. Good. Okay. Any questions on that last property, change of base?